Good morning and welcome to our last lesson of chapter 4, and that is interpret two-way frequency tables today. And we're also going to really learn how to make relative frequency tables today. If you need to pause the video here to get the definition, you can. Basically, though, what a relative frequency table is it's going to show us now the ratio of the number of data per category compared to the total. All right, so let's get right into the first example here. So it says, Caden asks 150 parents and students about their preferred method of communication. Make a two-way frequency table. Okay, so we learned this yesterday, so we'll go over that again. And then make a relative frequency table to show what percent of people were students that preferred email. Okay, so here's his data. You might want to copy this down on a separate sheet. So he polled the parents 18 preferred email, 12 preferred text, and he polled the students 18 preferred email and 102 preferred text. So our first job is to make the two-way frequency table. So let me remind you, to do that, we start by making this off-centered T looking thing. And what I try and tell everybody is that we X this part off because you're not going to use that space, and sometimes it gets confusing if we don't X it off. Okay, then we're going to fill in some information and what we're comparing. So we can really use kind of how he's set this up and set it up in an actual table. So our frequency table, our parents, we need, and we also need a row for students. And the only thing he's missing on his original data here is then we have to end all two-way frequencies with a row for total, okay? And what are we comparing this to? We are saying what parents prefer email, what parents prefer text, or students, and then again, we still need a total here. Now, if you're being technically correct, you would label this side probably people, and you would label the top here method of communication or something like that. And so I don't have it on here because of space, but I should. So you could label that again, label this side people, and method of communication. All right, now we're going to fill in the regular two-way frequency table. So the information that we are given here is that parents, 18 prefer email, 12 prefer text, 18 students prefer email, 102 prefer text, and then we get these totals by adding them up. So 18 plus 12 is going to give us 30 total parents that must have been polled. Students here, 18 plus 102 is going to give us 120 students that were polled. On email, 18 plus 18 is going to give us 36 total people that preferred email, and then 102 plus 12, or the other way around, 12 plus 102 is going to give us 114 total people preferred text. And then going this way and going this way should be the same. 150 total people were polled. This is a two-way frequency table. Now, what we want to learn today is how to use this two-way frequency table to now make a similar table, but this is a relative frequency table that we're going to make here. Notice it's set up the same way. We're going to start by making that off-center T. And again, we are not going to use this top box here. Okay, so we're going to X that out. We still are actually going to use the same categories that we used in the frequency table. We're still going to have parents, and we're going to have students, and we're going to have total this way. And you can flip-flop these as well, depending on how you decide to set that up. It will give the same information, just in columns instead of rows. Email, text, and total was this side. Now, the difference with a relative frequency table is that in the box now, we want the percentage of parents that preferred email. So to get the percentage, we need to do the total that we saw here, 18, out of the total people together. So what we would do is we're going to take 18, and I'm going to use a separate piece of paper underneath here to show you. All right? So we're going to take this 18 out of our total 150, and we are going to get a decimal. And so if you have a calculator handy, that would be good, right? So 18 divided by 150 gives us a decimal. So we get 0.12, but we want this as a percentage. So you can either know that a percentage, you move this decimal 2 places out to our right, or you can multiply by 100, okay? And so it's 18 divided by 150, that gives you 0.12, times 100 gives us 12% of parents that prefer email. Okay, let's do it again. So let's see what percentage of parents prefer text. So again, you go to your frequency table, that was 12 parents out of 150. So you're going to do 12 divided by 150. And then you can actually do this all in one swoop, and you would multiply by 100 to get your percentage. So let's do that again. 12 divided by 150 times 100 gives us 8% of parents prefer text. Okay, now to get the total, you add the percentages. 12% plus 8% gives you 20% of the total that have been polled are parents. Okay, let's do it for students. 18 out of 150. We already did that for the parent, right? And if it gave us 0.12 times 100, that gave us, 12% of students prefer email. All right, let's do the text. Wow, this is a much bigger number. So 102 students out of a total of 150 people. Okay, let's do that. 102 divided by 150. That gives us 0.68 times that by 100. All right, so 0.68 times 100 gives us 68% of the students prefer text. Do we find that surprising? No, probably not. 12% plus 68% is going to give us 80% here of the people that are polled were students, okay? And now we have to add going down, 12% plus 12%, 24% of the people polled preferred email. 8% plus 68% is going to give us 76% of the total people preferred text. And then adding this way and adding this way, this number here should always be 100% because you have to take into account the entire population that you have polled. So this here is a frequency table. This is a relative frequency table. Okay? One gives the actual numbers and one gives them as a percentage. Okay, now let's do one other example here for the video, and then I'll talk about what our homework is if you have me for math class. All right, so on the next page of your notes here, this is pretty much the same deal, only we have the frequency table already filled out, and we have to fill out the relative frequency table. So this one says, Asha asked 82 classmates whether they play sports on the weekend. The results are shown in the two-way frequency table. So here is the frequency table right here, right? So the people polled are boys and girls in total, and the sports on the weekend, there's either yes, you play on the weekend, no, you don't, and then the total. Now, this is all filled out. So to get the percentage, which I know you can't see that very well, but that's just a percentage sign here. What is the percent of boys that play sports on the weekend? Okay, so we're going to take that total, 21 boys, out of the total that they polled out of 82 people, and we're going to multiply that by 100 to get it to be a percent, okay? So 21 divided by 82 times 100 should give us, divided by 82 times 100 gives us now, and I want to show you this on the calculator, right? It gives us this big, long, crazy decimal. So in this case, it's standard for us to round to the nearest tenth. So tenths place is the first number after the decimal. So 25.60 is the next one, so we're going to round that to 25.6%. Okay? And then we'll do the same for the next. 18 boys do not play sports on a weekend over the total of 82 people polled times 100. So 18 divided by 82 times 100 equal, now this one, let's show you on here, says 21.95, okay? So when we round that, 21.95, that 5 rounds that 9 up again, so we're going to actually round this to 22.0%. 22.0% here. Okay, so let's do girls. Girls would be 26 out of 82 times 100 for the yes category. 26 divided by 82 times 100 gives us, again, we got to round again, 31.70. So we're going to round that to 31.7%. And I'm going to put those percentage signs back in there. All right, how many no's were there? 17 girls out of 82 said no. So 17 divided by 82 times 100 gives us the percentage of 20.73. Now, the 3 is lower than 5, so we're going to round that down to 20.7%. Okay, now let's get some totals, and this is where it might get a little bit weird, okay? So we'll clear this out. So if I add this up, 25.6 plus 22 to get this one, I get 47.6%. Okay, if I go this way, 31.7 plus 20.7, I get 52.4. Now, if I add going down, 47.6 plus 52.4 should give me exactly 100, and it does in this case. Let's see if it does it the other way. So 25.6 plus 31.7 to get this column is 57.3%. 22 plus 20.7 gives us 42.7%. Oops. All right, 57.3 plus 42.7 gives me exactly 100 again. That's really nice in this example. Sometimes, though, because we are rounding, we might be like 0.1% off depending on how we do because we're rounding the percentages. But we should be very close to 100 when we add this way and when we add this way. Okay, that is the lesson for the video today. And if you are in my class, we are going to work on 4-5 additional practice as our assignment today. One thing I want to point out to you is that number 1 on this goes all the way down, okay? So that is number 1. And then number 2, this all goes with number 2. And then, weirdly enough, number 3 goes across like this. So it's just the way to fit everything on one page. And then there is a back side that is to be completed as well. So 4 goes across, 5 goes across, 6 goes across on the back. Okay, If you have any questions, please feel free to email me. I'll get back to you as soon as I can. Have a great day.